On the previous one I also went up on the front right.
Well, a shock is basically controlling the spring. That's fundamentally what the shock's doing. The spring is controlling the attitude of the car in the long speed corners. Basically, once the car has taken a set in a long corner, it will have taken the set on the springs that you've got on the car, or the bump rubbers, whatever your sprung package is. Right now, we don't have bump rubbers in the car. The inerters work better without bump rubbers in the car, so they've come out. But because they do their own job of controlling the ride height movement of the car, controlling the tyre load variation, and damping out the high frequency stuff. Yeah, the sort of high frequency bumps and that sort of thing. The inerter will sort of drive a straight line through all that, and that's the benefit of them. So they're doing part of the job that the bump rubber did in a different way. The bump rubber was basically another rising rate spring further into the bump travel. Now we've got these throughout the bump travel, so they work in a different way. It's a very complicated subject. There's a big subject, and I think what we'll end up doing is doing an inerter sweep. The amount of inerter that we can afford to run at each track will be different track to track. So that will be one of our key points to get right at the beginning of a weekend is where the inerter needs to be. Underneath that, there's the damper shim stack, which is on the piston. So you can change the piston design from a digressive linear or a linear or a variable bleed piston. You can from these pistons and the shims that go onto them, you can create a myriad of different damper curves. And a curve really starts at zero speed, zero velocity, at zero force. And a damper is a speed sensitive device, so the faster the damper moves, the more force it creates. And so the shims that you put onto the piston vary the amount of force you get at different speeds of damper velocity. And so you can then control what happens when the driver first turns into a corner, which is generally low speed damping, and then what happens on a bumpy circuit, which is higher speed damping. A slow corner will have high speed damping, and a fast corner will have low speed damping. So Big Bend has got lower damping velocity than turn 2, for instance. So you can tune a car between the high speed and the low speed corners on damping as well as spring. And if the car's attitude isn't correct in a high speed corner, it's because it's on the wrong spring rate or the ride heights are wrong. You can affect the attitude and the transient handling of a car in the low speed stuff with damping a lot more. But it's what the driver feels at the steering wheel and what happens at the initial input is all that sort of low speed stuff, and then how the car responds over bumps and curves and that sort of thing is in a different speed range. So you play one off against the other and you come up with a curve, a damper curve. It's all about controlling the tyre at the end of the day. It's controlling the load variation of the tyre and controlling the spring that you've got on the car.